Basics series in the data science bootcamp program. So it's been an amazing week. We started off with introduction to ML in the first class, and then we went through the different types of supervised learning algorithms. We started with the regression problems. And now today we'll be going into classification. So for the regression class, we did two particular data set. We explored two particular data sets, and that was the Boston and the USA housing. And last class, I shared the notebook on the LMS. I don't know if you all saw it, and there was an assignment. I'm sure, I don't know if we saw that assignment as well. So I'll just point you to where the location is so that you can, try your ends on, or I don't know if anybody had tried their ends on that assignment, the e-commerce assignment, because I've not seen any submission yet. Okay, thank you for joining once again. Thank you for your contributions. Thank you for your support. Okay, so and we would continue from feature selection today, but I just want to show you the assignment that was uploaded on the LMS. Okay, so it was uploaded under the class recording. We have the okay, so we have the class recording. I just want to put it on focus mode so that we can all see it properly. Oh, sorry, my system is hanging. Okay. I don't know why my system is hanging. Let me just reload this tab. Okay, still loading. All right. Okay, so this is where it is. This is the exercise that you're supposed to try your hands on, and you just try your hands on it so that you further strengthen your understanding of the concepts, and then you can submit your assignments via this link. So today we will be we'll be we're starting classification today, but then I want to touch on feature selection, which is a very key concept when you want to optimize your machine learning model. So last class, we explored the Boston house prices data sets, and then we built a machine learning model using linear regression. But then we got RMSC score of I can't remember the exact score now, but it was not very good. It was not a very good score. So how do you further improve the performance of your model? All right, so that's the essence of feature selection. So there are several things to consider. There's several things to take into consideration when you have to improve the performance of your model. Okay. All right, Otabio, I got your message. That's okay. That's fine. You can. All right. So if you want to improve the performance of your model, there are different things to do. But one of the things that can be done is feature selection. And what is feature selection? It's a process of identifying and selecting a subset of the input variable that is most relevant to the target variable. What am I saying in essence? On your data set, you remember you have your features, and then you have the target that you want to predict in a supervised learning problem. And in this case, this is regression. So for some data sets, you could have as much as 20 features, 100 features. How do you, most times when you build machine learning model with all of those features, right, it might not give you the best results as desired. So what else can you do? You can actually use feature selection to streamline the features, to reduce the number of features to a very good size, such that would be a good input into your machine learning model. And so that is why you're doing feature selection, because in regression, the strength of the relationship between the input variable and the target variable can be calculated through correlation. So correlation is one of the ways to do feature selection, and of which we tried that out during the Boston House Prize, but we didn't implement it. So I'm going to show you how to implement that in this notebook. All right. So what are the benefits of performing feature selection? So feature selection reduces overfitting. And what does overfitting means? It means that when your data set is as actually at length, when you're building your machine learning model, there is this learning that is taking place. Your model is learning on previous data, on historical data. So there's a process of your model over learning all the relationships and patterns, such that when it sees a new data set, it does not do well. It fails on that new data set because it had learned it had been, that's the concept of overfitting, when your model has actually learned several complex patterns, and then it had gone to a stage of it being redundant, and it's not able to perform well on a new data set. When your model does not generalize well. Okay, so it's going to be an issue. Overfitting is a big issue, but feature selection helps you to reduce that. When you're building your model with maybe lots of data sets lots of features that are irrelevant, it introduces noise to your model development process. It will introduce noise to the algorithm, such that the model is learning some irrelevant things that it's not supposed to be learning. And thereby, eventually, it might be giving you a very good accuracy on the test data, but when it gets to the real life a real life implementation, it fails on a real life implementation. So that's part of why you do feature selection, you do model optimization. Feature selection also improves accuracy. That is, it reduces the error in your data set. It helps you to focus on the most relevant features, and you're building your model on the highly relevant features in your data set. Also, it reduces training time. So the time taken, if you calculate the time taken to build a model that was trained with like maybe like 100 columns, and the time the difference between the time taken on a model that was built using 100 columns and the one that was built using 10 columns is a very, very large time difference. And what that means is that it's going to cost more to build. For example, if you're not using your local system to build this model, maybe you're using the cloud storage, you purchased credits in dollars for cloud storage like a GPU, and you have to build your model with that large data set that eventually will give you a relevant, maybe that might give you a relevant response. And it's going to cost a lot of money compared to you focusing on the highly relevant features, and then you have a reduced column to build your data sets with. So those are the advantages, some of the advantages of feature selection. So how do you implement that? So there are different types of feature selection strategies. In the popular ones for regression, we have the correlation statistics and the mutual information statistics. And I would explain what that means. We have an idea of what correlation is, right? Checking the difference between we want to see the relationship between two variables. You want to see whether it's highly correlated or it's it's not correlated at all. So correlation is within the range of -1 to 1. So when the correlation is actually 1, that means that the two features are very, very, highly correlated between one another. That is one, maybe as one item is increasing, the other one is also increasing. So I'm going to show you an example. Let's use the same Boston data set that we used during the last class. After importing all our libraries, I'm going to read in the data set. So I'm going to rush through this because of our time. We have a lot to cover. All right. So but then you get the basic concept. So we have this data set which we looked at last class. This is the median value that we're trying to predict, and we have like more than about we have 6, 9, 12, 14 features. 13 features are they are the ones that I want to use to predict the median value. So we're going to say 13 features and one label. All right. So we have two popular technique, which is the correlation statistics and mutual information statistics. And correlation is just the measure of how two variables change together. Maybe as one is increasing, the other is increasing, or as one decreases, the other is decreasing. I've mentioned that already. And we have different type of correlation. We have the Pearson correlation, and it assumes a Gaussian distribution to each variable, and it reports a linear relationship. So I'm going to just skip all of those. I'll give you references to also read further if you would like to know some of the mathematical concept behind that. But then in implementation, there is this library called the feature selection under sklearn. So we have the feature selection library where you can import the F regression function. So the F regression function is it's used to implement correlation statistics in in your regression problems. It's not limited to linear regression now. So feature selection is you're performing on your data set. That's what you're doing. So when you use this correlation function on your data set, then you can use the SKBest. There's another function called the XKBest, which helps you to select if you want to select maybe the top 10, the best 10 features, the SKBest function would help you to achieve that. So how do we use that? So I'm going to explain this function that was defined. It was defined by my own written function. So I'm going to just explain what it's all about. So when you want to implement it, the first thing is you will select your X and Y. That is, your X are your feature columns, and then your Y is a target column, right? There are different way of doing the selection. So you could also say Boston dot. You can select the columns using the double square bracket as well. So however, I'll use the drop method to do your selection, but I'm using the ilog function method in this case. So I haven't selected your features are your targets, right? You have your data sets, and then you do your train test splits, your X train, X test, Y train, Y test, and you have your values. So I'm going to load this quickly. So you have your X test, X train, and all of that. Train test is not okay. Let me load my import statement. I guess I loaded that. Okay, here. I've not loaded this. All right. So here, I'm going to load my train test splits. Now for the feature selection, right? What you're going to do with the feature selection, we defined a function called the select features. And so what this does, it takes the X train. So let me copy this so that it will be in a synchronous format. So after this step, you can create a function that takes the X train. Here now you have your X train, right? This is your X train. This is your X train. Let me just do .add. All right, you have your X train, you have your X test. So it's just a part of your data set, maybe like 66% of your data set. That is the training set. And then the remaining 33% is your test set, your X test. So you're going to create a function that has the X train, Y train, and X test as inputs. Now, the function that was imported is SelectKBest. This SelectKBest import function. You can instantiate it using a variable called, maybe any variable, equals SelectKBest. So it has this score function that can be defined. Here, this score function, you're giving it the type of feature selection strategy that you want to use. So this SelectKBest you can use different feature selection strategies. You can use the F regression. You can use the other one, the mutual information statistics, and or different score functions. So if you check this function, you can see that, and you read the documentation. Sorry. So if you read the documentation, it tells you that you can load, you can use the chi-square. So there's another one called the chi-square. So there are different type of feature selection strategies. Chi-square is used in classification. All right. So here you can see, okay, this is the score function, callable. Function takes two arrays, X and Y, returning a pair of arrays or a single array with scores. So this is a function that is the function that you want to use for your feature selection. And in this case, it's our F regression function, this one that we imported. All right. So by default, it's the same formula you use if you want to use it for other data sets. So it's the same thing. So you can just say select KBest, the score function, and then you define your K. Do you want it to select all, give you all the scores of all the features in your data set, or you want to give it, or you want it to give you the top 10. So it depends on, this is where you define the number of K value that you want your feature selection function to give you. So here in this case, I want to see all of the scores of my feature selection model. All right. So here, after you've instantiated the model, then you fit it. It's just like you're building, you're implementing you're building a model. All right. So you're going to fit it with your X train and Y train. After fitting it with your X train and Y train, and then you would now then transform it using your fs.transform the X train, and also you transform the X test, and then you return your value. So this is just the function, and this is the way it works. So having defines this function, you can now use this function, and in this case, you are giving it your X train, your Y train, and the X test that you had already splitted here. So you've done your train test piece. You have your X train, X test, and your X train, Y train, and X test. So you're going to use that same X test to fit your function. After doing that, so here, this had already done the feature select. You've applied the feature selection algorithm here. And so now you can now see, for you to see the values of your feature selection score, you can now use a for loop to retrieve the values in your feature selection score. So you can either use a for loop, or you can use you can just use print the score. So let me print the score for you without the for loop so that you see what it looks like. So I haven't done this. I can run my feature selection, and then I have fs.score. So it's giving me in an array that is for each of my feature. The first feature here, which is our cream. Our cream is ranking 66. The other one is ranking ZN is ranking 65. The other one is ranking 98. And to the end, to the last one, to the L stats, which ranks 407. So here I'm just using a for loop. I'm looping through this particular array, and I want it to add the labels to it. That is the column feature 0, which is 66, feature 1, and all of that. You can either write it this way or you write it this way. When you do your plot, you can see that feature 12 has the highest ranking, which is about 407. And our feature 12 is what the L stat, and that's the highest correlated value in our data set. Okay, so if you go further, you see that here is another way of printing your features. Here you can see that you can define the scores in a data frame and also define the column names this a data frame and join them together. So that's what I just did here. So I joined the two columns, that is the score and the columns together, so that it can form a table. So you can see it here that the L start was the one that gave me the largest score, followed by the room, followed by the PT ratio, the indoors, the NOx, the tap. So here you can see the ranking of each of those features. So here I told you to print the N largest feature. So if I wanted to print if I just wanted to print 5, it's going to give me just the top 5 features in my data set. So here it had applied that correlation algorithm on our features. Automatically you can see that you now know which feature is actually performing well. It helps you. You can't say, you can't tell totally whether these features are performing well, but then it gives you an idea of the features that you can use as inputs in your data set. So if you had built your machine learning model with all of your features initially, you can say, okay, can I select the top 8 and let me use the top 8 features to build my machine learning model, and let me see if it's going to give me a better accuracy score or reduce the error. So that's part of how to deal with optimizing your model. So here you can see that you have your features. These are the features, and then you have the scores alongside. And here you're just doing a plot using features.plots, and then you're giving a kind of plot you want it to look like. And see here, it's just showing you the graph of the features that are in your data sets and their ranks. Okay, so that's the correlation matrix. That's the correlation statistics method of feature selection. So the next method is the mutual information statistics. And here same it uses another concept. So we have different people come up with different solutions to having to select the best features. So they've written all of these algorithms in a function. We did function in Python. They've written all of this algorithm in a function, and so that we can import those algorithms and we use them in our model development process. So we have the mutual information feature selection, and this is actually used in information theory. It applies the principle of information theory to do feature selection, and it's typically used in the construction of decision trees. So decision trees is like a tree-based algorithm where most of us have applied decision tree. By the time we get to classification algorithms, I would explain more of the decision trees. It's used a lot in classification, but we also use the regression as well. But I would explain more of it in classification algorithms. But let me just focus on feature selection algorithm for now. So mutual information, it's used in the field of information theory, and then it applies the principle of information gain such that it calculates the two variable and checks which one has reduction and uncertainty regarding the other variable. So it's used as well like the correlation matrix, right? You can use it. It uses this mutual info regression function to calculate the feature selection algorithm. Just like we did with the F regression, You can also import it from the sklearn.feature selection. You remember that when we're doing the F regression, we also imported it from feature selection. So what you're just changing, you're still doing the same thing, the same process, but the only thing you're just changing, you're changing this F regression to mutual information regression. That's the only thing you're changing. That's because the way of applying it is the same thing, the same process. So I'm going to run through it again and explain how that is done. Okay, so the same thing, after importing it, we define a function that accepts the X train, which we have splitted, the Y train and the X test. And then we configure it to select all the features, or you can configure it to select some of the features based on whatever your need is. All right. So you're going to use the SelectKBest function. Then you change the score function to mutual info regression, and then you define your K, whether you want it to be all of the values, or maybe you want it to give you the top 5, the top 10, or however. But in this case, I'm using all. Then you do a fit. So if you notice in machine learning, right, most of the algorithms you're using, just like if you're this is the way we build our model. We define our model. If it's linear regression, we do a fit, right? And then we do predicts. But in this case, we are defining our algorithm, which is the SelectKBest. We do a fit with the X train, Y train, and we do a transform, because what you're doing when you do a fit, the fit is fitting this function, which is escape, this function that we have inside FS, with our training and our X train, that is all of the features, and the Y train. So the X train is looking like this. This is your X train. This is your X train. Everything from here to here. Let me go to the main data. So everything from prim to L start is your X value. Everything from here to here. Sorry, I can't highlight it, everything from here to here is your X value. Then MEDV is your Y value. So when you say X train, that means you splitted this data set. If this data set is 20, maybe you've splitted it into 18, 2, where 18 is your X train, and your the remaining 2 is your X test. And this is your Y train. The 18 of this Y value is your Y train, and the remaining 2 is your Y test. So you are fitting the algorithm on your X train, Y train, right? And then after you've fitted the algorithm on your X train, Y train, you want to transform it on your data set. All right. So what you're doing is you're applying that algorithm on your X train, and you're also applying it on your X test, and you're saving it into a new variable such that you have your new transformed feature selection and your on your X train and your X test. So you have the new values for your X train, X test, and your feature selection. So when you have this, right, you can now use this to check for your future selection score. So here you can see that your X and Y, then you do your train test split, and this is where you're actually applying that function you define, the select features function. And here now you see that you can print. Let me load this. Okay, I didn't load the mutual information regression. All right, so let me load this again. Okay, so here is not defined. I thought I've loaded it. Okay, yes, it's fine now. So here I can now do this. I can say my FS score dot score. That's where it's stored with the score values of all the ranks of each of the scores. Sorry. You can see that this is different from the mutual information selection, is different from the F regression, right? Because of this, they have different algorithms used to do their feature selection, their strategy. So you can see here that the scores have been given. So I'm going to convert this into a data frame. Let me use this method, a pd.data frame, the scores, and then the columns in my data sets. All right, and then I concatenate the two together and print the results. You can see here that in this particular, using this strategy, L-start is still our best feature, right? Followed by Indos and Rome. So let me, if you compare this one with this one, you can see here, okay, that L-start is still the best, but then instead of Indos was second under the mutual information, but here we have the room as second. You can see because of the different algorithms, we have the different feature selection process implemented, and we have different features. So you can now decide based on these two algorithms, which one do you want to, how do you want to select your feature? It gives you an idea of what feature, right, you should use. So most times in machine learning, you do a lot of iterations with your modeling. So you do it. That's why you have to learn how to use Python very well so that you write functions and to automate your steps, because there are several iterations you'll be doing over and over again. So now I haven't seen these two feature selection strategy, the mutual information regression and the correlation regression function. You can see that there are two different strategies which can be implemented, all right, on your data set. So when you have applied this feature selection process on your data sets, it would guide you on which data sets which feature to use as inputs to your linear regression model. So you can go further. Because of our time, I want us to go into what we have for today. I intended to just spend 30 minutes on this, right? So I want you to try the linear regression model with all the features. Let me change this to Markdown. Try a linear regression model with all the features, with the top features in the correlation statistics and with the top features in your mutual information regression statistics. So you're going to use the two different features. Try your linear regression model with it again and see the results of your model, whether it's going to be better or it's going to be a worse model. So I want you to try your hands on that as well. At this point, do we have any questions before we move to the next thing? Do we have any questions? Do you have any questions? Okay, we have a lot to do. And okay, Alabi, okay, please, what's your question? If you can be very fast about it, I just allowed you to talk. I've given you access to the mic, you can talk. Or you can drop your message if you don't want to talk, you can drop your message.
Oh, sorry. I didn't know I was muted. Sorry. Good evening. Please, I tried to log in my learning portal earlier this week and I could not find the courses. So I was wondering what's going on. I don't know if there is something that happened along the line that I'm not aware of.
Okay. Okay.
Thank you.
All right. Okay. All right. Just send a mail and then send the mail with your email. The email that you used to log in. We'll check what's happening. All right. Okay. Do we if you have any other question, maybe we could just drop it in the chat. I would attend to it during the open session so that we can just move to the next thing. If it's not relating to the feature selection, I just explained. All right. Okay, so at this point, I want us to go into our classification algorithms. So I mentioned earlier that we have different types of in machine learning, we have the supervised learning, we have the unsupervised learning, we have the reinforcement learning. Under the supervised learning, we have the regression problems and we have the classification problems. So we just finished dealing with the regression problems. By the way, we have other regression algorithms apart from linear regression. So it was the only linear regression actually touched on. But when we are doing a recap, probably I'll try to maybe during our capstone projects, I could just touch on other algorithms or if we have more time. But for classification, I think I'll just do more algorithms. All right, so that you can also see the different type of algorithms that we have in classification and how to use them, in regression and how to use them. All right, so I want us to go touch on classification, at least part of classification today, then we'll continue during the next class with a wrap up of the classification algorithms. Okay, so under classification, right? Mentioned earlier that classification problems involves the prediction of a category when you have to predict a known label that is a categorical variable. And when I mean what do I mean by categorical variables? Like variables that has to do with maybe true or false, yes or no, high, low, medium, anything that has classes. So that's has to do with the classification problem. And we have different use cases like spam detection that we use during our email. It's used in maybe in most of our mails where we classify any mail coming into your mailbox is being classified as either a spam or a normal email. And now we have even different categories on our email. We have promotions, we have updates. If you're using a Gmail, you have promotions folder, you have updates. So you didn't create those folders. Automatically, those emails were sorted for you using classification algorithms. All right. So we have the churn prediction, whether it's when you're predicting whether a customer would actually churn or not. Is used mean a lot in sales. We have sentiment analysis, when you have to analyze sentiments of maybe Twitter statements, and then you want to know whether the person was actually angry. You can classify the sentiments as maybe angry, sad, happy, different classes of of sentiments used in sentiment analysis. It's used in anything that has to do with classes is used in in health related data. When you want to predict whether somebody would have a particular health disease, maybe cancer or maybe malaria. You want to do prediction of malaria, you want to do prediction of cancer, you want to do prediction of different class. It's also used in agriculture. Maybe people that you can build a model such that is able to classify species of different flowers or tomatoes, or maybe you want to classify the species into different types. You want to predict the type of the species of a particular variant of crop. You can use classification algorithm to achieve that. So it's a very good, great. I mean, it's a very, very wide range. You can apply it to different use cases. Now, let us go further to, let me explain some of the different types of tasks we have. So in classification, we have the binary classification and we have the multi-class classification. So under the binary classification, you're actually predicting just two categories. You're predicting whether yes or no, true or false, high, low, spam, not spam, churn or not, something that has to do with two categories. But when you're moving from two categories to three categories, four categories, for example, when you have to predict the digits, you want to predict the number of digits from 0 to 9, right? So that is a multi-classification problem. Or you want to predict who will win election, a party that will win an election. We have many parties, we have many classes of parties. Maybe you want to predict among the top five parties, You want to know which of the parties will win an election. So you can gather historical data, apply your classification algorithm, and then you're able to build a model that does that such predictions. So you use a classification problem classification algorithm to achieve that. Now, this is the plot, unlike regression. What regression does is regression is trying to give you a perfect line of best fits, right? She wants to show is trying to create a linear relationship between your data set. But in this case, you're trying to classify your data set into different categories. So in this case, you have in a binary classification problem, probably here you have score and you have grade. I want to use the score and the grade feature to predict whether a student would pass or fail an exam. So the blue circles could be pass, and then the red circles could be the red shape could be fail. So you want to look for a perfect line that separates these classes, these categories into different classes, right? So that's what you're doing in a classification problem. You are trying to look for how to perfectly separate these two categories. Yes, two categories into their different groups. Okay, so that's what you're doing in a binary classification. But in a multi-classification, where you have more than two groups, so in this type of group, you have like your assessment as pass or fail, right? But here, maybe you have more than two categories. You're having, maybe, for example, you're having high, low, medium. Maybe you're trying to predict whether the temperature of a particular substance using two features, and then you want to predict whether it's going to be a high, a low, or a medium. So in that case, you're dealing with a multi-classification problem. So it's still also what you're trying to do is you're looking for how to divide each of all of these categories into their different groups, such that this is your model. The line that you're seeing here is your model. You want to build a model that would learn, that would form perfectly divide each of these groups, such that any new category coming in would fall into their rightful category. Any future data points coming in will fall into their right category by applying this model. I don't know if you understand what I just explained. All right. Okay, so moving forward, Joseph, I'll attend to your question after after this break. I'll attend to your questions or towards the end, so that I don't want to break the session now. All right. So there are different type of classification algorithms that you can use in classifying your data sets. So the popular ones are the logistic regression. Logistic regression is very popular. You have the logistic regression, you have naive Bayes classifier, you have the nearest neighbor, support vector machines, decision trees, boosted trees, random forest, XGBoost. There's so many algorithms that can be used, right? And then it depends on the kind of data sets you have, right? But at the simplest case, you can use your logistic regression model. So for logistic regression, we'll be doing, for this class, I'll be explaining quickly using a use case, what your logistic regression model is, and then we'll be looking at how to build a logistic regression model using one of the data sets. Okay, so here we're going to apply social network data. We're going to use a local social network data to determine if a particular person purchased an ad or not. So we want to use a logistic regression. We want to build a classifier that's going to classify the data set as maybe somebody purchased an ad, or somebody would like to purchase an ad in future, or they will not purchase and add in the future. So then before we get into that, I want to explain what the logistic regression does. I mean, how it works. So the logistic regression model is a classification model. It's also a linear model with a binary response, true or false, or zero and or one. And it's has this binomial distribution, unlike the linear regression. Linear regression has the equation of a straight line, y equals mx plus c. But the logistic regression uses a sigmoid function to transform the values of this particular function to 0 and 1. I'm going to show you the graph of how it looks like quickly. Let me just explain this. So what it does is that it calculates a function. When you have, this is f of x equals 1 over 1 plus e raised to the power minus x, where you have your x and then we have the error x minus x naught. All right. So what it does is that it looks at it takes your data sets and then it checks the value. It calculates a probability function, and it gives the probability function gives you a particular value, and it maps it to whether it's going to be a 0 or it's going to be a 1. So this is the way the sigmoid function looks like. It's called a sigmoid function because the values are within it gives a binary response between 0 and 1. Okay, so this is just a graph plotted, and this is the equation of the logistic regression. That is, you're doing your this is maths dot exponential v divided by 1 plus maths dot exponential v for v in x sequence. So this is a range function of values from -7 to 7 with a step of 0.1, and that is what it's calculated here. You have your -7 to 7. This is -7 to 7, right? With a step of 0.1. And then you have your sigmoid function between the value of 0 and 1. So the logistic regression, after it applies that function on your model, right, you get a particular value. Your value can be 0.4. So if your value is 0.4, then it assigns it to he assigns it to whether it's a 0 or a 1. If your value is 0 is maybe like 0.4, so that is below the threshold of 0.5, it makes it 0. Then if your value is maybe around 0.6, 0.8, it says is 1. So that is how the logistic regression works. So I'm going to explain, maybe as we implement it, you're going to be seeing what I mean by that. So let's look at how it works in application. So I'm just trying to give you an idea of how, because most of all these algorithms, they have their mathematical equations and concepts behind it, and when to use them, when not to use them. So some of these algorithms, you might have to, read them. You have to read up on them if you want to know them more in depth. But then if you just want to apply them, it's easy to apply, right? But then if you want to go into more advanced and technical machine learning development, you have to know some of these algorithms and what they do. Okay, so this is a social network data, and it's an advert placed, whether some persons purchased an advert or not. So after reading in the data set, we have the user ID of the people, the gender, the age, the estimated salary, whether they purchased an ad or not. So after doing that, you just want to, do some data, checking the data, check the value count of your gender. You see that we have just two categories. So this is a binary classification. We want to classify whether somebody would eventually, haven't known the person's name, I mean, gender, age, and estimated salary. Want to know if the person will purchase an advert on maybe your social site. You have a social site, maybe just by knowing the person's age. So there could be, so this is just a very simple data set. In real life, you have many more features, and that's why we do all this feature selection. You could have, on Facebook, for example, if Facebook wants to apply this kind of model algorithm on their sites, they have several parameters. Facebook has the data of set of people's location. They know your location. They know your school. They know your friends of friends. They know so many data sets. So if they want to know if you're going to purchase an ad or not, they can build a model such that they gather historical data of several other Facebook users, right? Or they want to know whether you click on an ad or not. They will gather all your data set of users on their sites, or they just do a sample set. They might not use everything. They'll use almost from different categories. So there's something we call like stratified sampling. You take samples from different categories of people so as to build your model with it. You might not be able to use the whole population of the world to to um to make a point, right? But you just take samples. You take samples from different categories. For example, if you want to build a data set that has to do with everybody in Nigeria, you take samples from different states in Nigeria, depending on your use case. All right, so Facebook would just take samples of data sets of different people, their age. They don't need their names. Maybe they need their location, their age, maybe religion, their occupation, the kind of their what they write about, so many things about them, and they can build the model. You can imagine how large that data set will be. And so some data you can't do it on your local system. It's going to crash. So it's that's where you move to the cloud. So you have to start your data cleaning process as a data scientist. Clean your data. Then you have to streamline your you have to carefully select the features that you need to build your model, because they want to you want to build a data set of, you want to build a model to know if somebody's going to click on an advert. You want to know the likelihood of if somebody clicking on an advert or not, right? So you'd have gathered data set of people that have clicked on adverts like that, and people that have not clicked on adverts on that type of adverts. Maybe it could be a technological advert, for example. So you could have gathered data sets on those categories, and then you have varied features, and then you now start building your model with it. So we have to explore our model, try to find out more information about your model. Here you can see that we have 204 to 196, so which is fairly good. So some peculiar challenges with classification problem is data imbalance, and data imbalance actually affects your model if you don't treat it properly. What do I mean by data imbalance? Data imbalance has to do with, for example, you're building a model to predict whether somebody is going to be diabetic or not. Usually, the kind of data set you'd have gathered, most people are out of 5,000 people, you could just find 100 people being diabetic, and the rest of the 4,900 are non-diabetic. So if you want to build a model with that kind of data set, you have to deal with data imbalance. If not, the data set, the model will learn. That's when the model will overfit. That is, it's going to learn more because it has very little very little occurrence. You are seeing just very little occurrence of people that are non-diabetic, right? The data set might likely still to always predicting that people will not be diabetic, because of course, for you to always, the data set the model has saying that out of 5,000 people, 499 does not have diabetic, but then 100 people have that. So yeah, the relationship that he had actually learned, he had learned more relationship on the people that are non-diabetic. So there is always a likelihood for that model to predict that the person will not be a diabetic patient. So there are ways to handle such cases. When we get to our model evaluation, would talk about that. But in this case, we are safe because our data set is just roughly almost 50, 50, 40, 51, 49. We have 204 to 190. Okay, no, sorry. I'm looking at the wrong feature. I'm supposed to look at the purchase. All right. This is, it's not so balanced, but then it's fairly okay, unlike a 90% a 90% or 80%, 80 to 20. This is just fairly okay, right? So which we can still work with. All right. So moving forward, you check you have to do your data exploration. You check your data, your target variable. You check different things about your data sets. You check for null values, check for duplicates. So if they are duplicates, you remove them. If they are null values, you have to decide whether you want to remove them or you want to keep them or you want to delete. There are sometimes that there was a data set I was working on. As I just imported the data set, I saw that data set was so large. I was so happy that, oh, I have a very big and large data set. And it had about almost 150 columns. And then I was super excited that, oh, this is but when I checked the null values, I saw that out of 100 and something columns, over 100 columns were empty, as in nothing was in that column. They were just empty columns. So if I'd not checked my data sets, I've just gone ahead to work with it like that, I'll build a very wrong model with that data set. So the first thing was just to drop all those columns that didn't have any information, because that would cause noise into my model, and that would even take time. It's going to waste resources. So you don't want to build a model that has something like that. So you have to check for your null values. In this case, we are safe. We don't have any null value. Yeah, so you can do your value counts on the purchase column. So there are several, when you're dealing with demographic data sets, there's something called fairness in machine learning. So machine learning is very, very wide, and it's just for you not to be overwhelmed. You just have to, learn systematically. Start, taking a little, you just start with the basics data set. Start, trying your hands on different type of problems. So as you work on those problems, you begin to see different variants of cases, of issues, right? You begin to learn other things alongside, right? Because if you're just, think that, oh, let me just, yeah, you can delve deep into it right away. But sometimes if I find out that so many people just get overwhelmed and get discouraged at learning machine learning. All right. So there's something called fairness. And in this case, there are times that you build a model and they say the model is biased because you have more people with a particular age range that is built, that that your model has learned those patterns. The model has actually learned pattern of people with a particular age range, so it's biased towards the elderly people. So when you have maybe demographical data, gender, age, so you try to also check for biasness or fairness in your data sets, like, or geographical data. Sometimes you hear that people say, oh, this model is actually built for Black people. It's when it comes to white people, it fails. I mean, it does not do well. It tells you it's not, performing well, most especially when you're dealing with natural language processing. It had learned a particular language, and when it comes to another language, it does not understand what you're saying. Okay, so all right, so let's just so you check the relationship, you check the distribution of your age with respect to the people that purchased and add what is the what is the relationship between those two tables. So I can just let me just do something quickly. Um we have the age and the purchase column. Okay, so I can just select my age and purchase. Okay. Okay, so I have 70 people, 70 ages here. I have age group 35. The people 35, we have about 29 people that are 35 years old. And well, visualization will help me, see this better. I'm getting there, but I'm just showing you something that you can see that people that are the people that actually really, really purchase the ads are basically we have if I look at the top five, let me just do the top five, the top 10. So the top 10, you can see we have this age range. They are majorly between 20s and the 40 people years of age, right? So you can see we have more of those people. And then the people that actually purchase adverts are within maybe 47 years of age. Let me do the tail of this data. The tail of this data, you see that the people that are purchased adverts are 40 something. We still have 30 something, 30 something, we have 30 something. So between 30 something to 40 something. So the people that are maybe lesser in age probably didn't purchase an ad. So, but by doing your visualization, you would see more about this relationship. But there are a lot of things to be done on your data set, right? So I just want to go right into other things because we have some other things to cover. So you can also group your data set using your group by the purchase column. So when you use your group by, you use when you want to do aggregates, we learned that during the Python class. You can use your group by, and when you use your group by, you can group the data set by your purchase column, which is one and two, and then you can take the sum, you can take the sum of the values, you can take the mean values. For example, you want to see the mean salary of people that purchase adverts and people that do not purchase adverts. So here you can see that the mean salary of people that purchase adverts the mean salary is $60,000 plus for the people that do not purchase adverts. Then the ones that purchase, we have about $86,000. So it tells you something that, okay, because maybe they have higher salaries and that's why they purchase the adverts. Anyway, but then we might not conclude that we have the ages to the mean age of people that purchase an advert, just like what we saw during that, when we sliced out this data set, you can see that people that are 46 years of age, the most people around that 40, they are in their 40s, and people that purchased, and people that didn't purchase are people that are around they're 32. Then we have more of now I don't know what this gender means because gender is actually male and female. So I can't really tell with that. I can't really tell with that number value. But then I user ID column, I don't need it. But for our age and salary, we can have an idea of what we're talking about. So when you do your data.describe as well, you could see the distribution of different columns. So here you can see the ages, the distribution of the ages. We have the minimum age as 18, the maximum age as 60. Is this correct? Maybe. Okay, yeah. The minimum age as 18, the maximum age as 60, the median age is 37, which is fair. The 75% percentile is 46. The 25% of the data set is 29. So this data set is likely to be a uniform distribution. We can't tell yet, except we calculate the mean and the standard deviation. Okay, no, it's not a uniform distribution. Uniform distribution, the mean is equals to mode and is equals to the median. All right, so it's not the same thing. All right, so we have the salary as well. We have the median maximum salary as 150,000, the minimum salary as 15,000, and then the mean salary as 70,000. So we can see that most persons are earning more in this data set. You have most person earn more. All right, so let's move further. we can do some visualizations with what we just, with our data sets. Here, you're checking the distribution between the people that purchase and the people that do not purchase. The number of people that did not purchase are higher, just like we saw, than the people that purchased the adverts. So here we can now, when you're doing your machine learning model, most times there are some machine learning algorithms that don't accept numerical, that don't accept string data type. They fail under string. They like the logistic regressions, and some of those regression are most, except the tree based, like your random forest, they can still handle string data types. But most of your linear regression, logistic regression, you have to convert them into categories. So we'll be doing in classification problems, you do a lot of data preprocessing. You have to preprocess your data, convert your string values to numerical values, and I'll be telling you how to do that. I'll be showing you how to do that. Okay, so let's move further a bit. We have we I think we left off here. Yeah, so now we can do a little bit of feature engineering. There are things we can do to these data sets. We can change the categories of this age into a categorical feature. Like we can give it a category such as 1 to 24, iGen, 25 to 35. So I don't know if this category is still relevant, because I think we now have Gen Alpha, Gen Zs, and the rest now. So let's still stick with this. All right. So we have 1 to 24 as the iGen, the millennials, the Gen X, and the baby boomers. So you can actually shape your date, your age column into another category. That's what you do during feature engineering. Like you create a new column out of existing columns. But most times before you do all of this, it's good to just build a model first with what you have. Build your model, because if you have done all of this and eventually your after all your work, your algorithm is giving you a very, very poor accuracy score, then that's waste of time. So usually you can even find out that this your data set in a simple case is going to give you a better accuracy than you doing your feature engineering. So you do feature engineering usually when you want to do a model, you want to improve the performance of your model, right? So but then I'll just show you some ways of how to transform. Maybe you want to create a new age, you want to create create a new age. You want to change the salaries into estimates, like maybe high income earner, low income earners, medium income earner, something like that. All right. So it's all of them are under data manipulation. It's part of what that's part of the Panda skill sets. All right. So but then I'll just show you some ways you can do this and how to go about this. So because we are going to alter the new table, the old table, the old table, I'm just going to create a copy of this data set so that we have a new, oops, okay, I think I'd already worked on this, so that's why it's showing. So let me load this and create a copy. Let me go back to the original data set so I can create a copy. Okay, this is where I loaded it. So let me just go back and create a copy. All right. Okay, now we have this. This is our original data set, right? So there are different ways to do it. You could use your list comprehension, and your list comprehension is just a short form of writing a loop. Instead of you doing your if statements and for loops, you can either do it this way. There are different ways. You can use your pd.cuts. You can do it this way, or you can do it using your for loop if else statement. So I'm going to explain how you can achieve all of that. Okay, using your list comprehension. So what you're just doing is that now these are the categories. You want your ages between, this is the age you have, right? You first of all identify what's the highest age and lowest age. Here, from here, we saw under our description, our data description, that the highest age, the maximum age is what? Let me go back to that's okay. The maximum age is 60, the minimum age is what? 18. So that gives us an idea of what our age difference is. Okay, so but because we want to take care of maybe future occurrences whereby you have other age categories and you don't want to be having null values on your data set, you could just also give a category of people that are not below 16, right? So let's say you have this category as your as your classifications. So the first thing is that using a list comprehension, you can create a new column using your age category. Now we want to create age category is not in our initial data set. You can say data, that's the name of your data set, age category. You amount create a new column. Then you have a square bracket, a list. You have a list. This is the open bracket and this is the closed bracket. Now, the first category is iGen. You're not saying that if iGen is 0, the last edge case is what? 0, is strictly less than the age less than 25, because you don't want, you see that they are none of them are, they are both exclusive. This is strictly less than, so this is actually 1 to 24, right? This is 1 to 24 because 0 is less than what? Age is less than 25. That's between 1 to 24. That is, if this is 1 to 24, then you should map it as iGen. Else, millennials, if so, this comprehension is very, very easy to use. Unlike you just write, you see the difference now when you're writing the for loop. It's a lot of complexities. Okay, so if the next category is 25 to 39, right? The else millennials, if 24 is not inclusive, 40 is not inclusive. So this is between 25 to 39. The same thing as Gen X, 40 to 54, and early boomers, 40 to 50. Okay, this is 40 to 54, right? So this should be 55. Okay, so we have else, then this should be like 56. Okay, so this is 40 to 54. Then this should be between 55. So this is there's a problem with this. Okay, I think it's from here. This is 40 to 54, and this is 55 to 73. Okay, that's okay. So this is 40. There's 940 to what? 54, which is correct. Okay. And then this one should be 55. So we are going to start from words. We are going to start from 54 to 73. All right. So this is for the baby boomers. Else, nothing else. It should be empty. Okay, then this is now where you put your loop for age in the list of. So if you're going to print out this, let me show you what this looks like so that you see what it looks like. This is data age. That is, this is the column that has the age. If you now say dot values, it's just going to give you the values of. So I want to calculate the length. Sorry, dot values. So it's going to list out create an array of all the age values. Then you want it to loop through this. You're converting it into a list. So that's what this is. This for loop is saying. Convert this array into a list. So you're going to loop through this list, and create all of these categories in this list. Then save it as age category. So when you do this, right, when you load this data set, you see that you have the new category. So you can see that 19 is iGen, 35 is actually what? Millennials, 26 is what? millennials based on our categories. You can see 2026 it should be millennials, right? 19 should be what iGen. So you can see that this effectively transformed, created a new column. All right. So all of this can be done in another way using the pd.cut. So for the pd.cut, I'm just going to use a simple data set. Now, this is an age data frame column. Let me just do it. Now, this is an age data frame column. Let me write pack data. So this is a data, just an age data, age data frame column. All right. So I just want to explain pd.cut so that you would understand. Now here, instead of you doing using a for loop or a list comprehension, you can create a bin and a label, right? Where your bin is the age, the intervals of those ages. Now here you can see that I want my interval to be around what 1 to 24, 25 to 39, 40 to 54, and 53 to 73. So I'm going to list all of those ages. So I'm going to list it. The first one is what? 1, 24, 35, 54, 73. And then this one, I just listed it as an edge case. So I didn't include 0 because what this is doing is that it's going to include the right, it's going to include the right age. That is, if you have, this is saying 0 to 24. Then this is saying what? 25 to 39, 39 to 50, 40 to 54. So it's already, what you're just listing out as your being is you're listing out those categories that you want in your data set. So it's saying iGen is what? Is 0 to 24. Millennials is what? 25 to 39. The edge cases, the hedge cases are excluded. That is, now it's going to start from 0 to 24. So the next one is not going to start from 24, it's going to start from 29 to 39 for millennials. For Gen X, it's not going to start from 39, it's going to start from 40 to 54 for Gen X. For baby people now, it's not going to start from 54, it's going to start from 55 to 73 for baby boomers. Then from adults, it will start from what? 74 to 110. So that's what this bin does, and your label. So you just create a bin and a label, and then you can now use the pd.cut. You can give it this age data frame, that is the column you want. Then you're now defining the bin, which has been defined here, then the labels, which have been defined here, and then you're setting that I want the rights to be true. That is, I want the right values to be inclusive. That is, -1 is left, 24 is right. So it's going to start, -1 is exclusive. So it's going to start from the next number after -1 is 0, 0 to 24. The left is exclusive, the right is inclusive. So the next one will be what? 25 to 39. 39 is inclusive. So that's what this does. And when you load this is what happens. So let me load it. You see what the new data set is like. Now you can see that you have your the age group already classified for you. You can see it that your 0 is what? iGen. 24 is what? iGen. 25 is what? Millennials. You see that I wanted iGen to be what? 0 to 24. You can see it covered that edge case. 40 is what? Gen X. I wanted Gen X to be between what? 40 to 54, which is covered. So that's another way to create that categorical column. So we have one more way. I think this is just a straightforward for loop. Because of our time, I want us to get to the end of building the models. Okay, let me explain this for loop quickly. So what this for loop does is that it loops through the date age column. Let me just check if We have questions. Okay, I'll take all of these questions. I'll take all of these questions after we are done with this session, so that I don't interrupt the recording. All right, so we have this we have another way of doing this. Okay, let me just stick to those two methods, right, so that we can move further. After you have created your categories, right, you have more columns to work with when building your machine learning models. Okay, so we can use the Q codes. Also, you can use the Q for your salaries. Maybe you want to create an income category. You can use the Q codes instead of just the PD.Q codes. You can use the Q code. So what the Q code does is that it creates a range of salary based on the quarter range, whether from maybe it picks the 25th percentiles and say, okay, this is low. Then between so and so number is medium. Between the medium to high is an high salary. So when you use your Q codes, it divides it into different, like 19 is low, 20 is low, 43 is low. Based on this distribution, we have this distribution table. Let me go back to the distribution table. Okay, so you have here, you can see that the minimum salary is what? 15. So you can say from the minimum to 25 is low, 25 to 50 could be medium, then maybe 50 to 75 or 75 to the maximum is high. All right, so that's what, based on the number of pots you want, you can divide it into 3, divide it into 4, however you want it to look like. So here, when you use the PD.Q code function, you can see that you have your income, your salary column transformed into your low, medium, and if I check other samples, let me just do data dots. I can't load it now because I didn't load this. Okay, let me just do data.sample. Sample, let me give 10 samples. So you can see here that 143,000 is I, 89,000 is I. Based on the Q codes, you can see what your the data set looks like. Now, having done all of this, right? All of this you're just doing a feature engineering. You can do your visualizations for the sake of exploration. You can see that the millennials are more than the baby boomers and the Gen X and the iGen. And you can see here that the salaries categories are actually almost the same based on the category, the way we categorize it. And then when you build a plot for each of them, comparing them to those people that purchased an ad or not, you can see that among the males, we have more males purchasing adverts than females. I mean, sorry, here you can see more females purchased adverts than the males. Here you can see that more of the Gen X, even though the millennials are more in this data set, but more of the Gen X purchase the ad. So here is already giving you an idea of people that would be good predictors when you're building your machine learning models. You can see that baby boomers, even though they are so small, they are one of the smallest in the data set, but we have more baby boomers purchasing adverts, compared to the iGen. iGen, there are a lot, but most iGen do not purchase. So now it tells you something that, okay, I think most people that are likely to purchase adverts are the people within this age range, not the iGen. The baby boomers, Gen X, and the millennials are the people that would likely purchase an advert. Okay, so all of these visualizations gives you an idea that, and then you can see that people with high salary purchased adverts than people with the medium salary. The low people even purchased more adverts than people with the medium salary, and I mean that medium salary earner. So you do a lot of data exploration just to have an idea of where features will be good for your data prediction. Now, moving forward, let us do our machine learning model, because that is one of the focus of what we are to do, right? So the first thing we want to do is we have to convert all of these iGen millennials into one, maybe into numbers, male, female. So because of for simplicity's sake, I'll just stick with the simple data set, that is the initial data set before the feature engineering. Because the idea of feature engineering, I was just showing you how to engineer your feature in case you want to maybe you want to optimize your model performance. But for the sake of simplicity, we're going to stick with the original data set, which is the first one that we have here that we imported. So let me just go back to run it so that I can have that data set in memory. Okay, so to prevent you running all those data sets, so you try to create copies of a data set as you progress in your modeling. All right, so here, so we have, this is our original data set. So there are different ways of encoding your string values. We have the label encoding and we have the one-hot encoding. The label encoding is, I'll explain what the difference is, between the two. Okay, I would answer some of these questions towards the end. So just stick around to the end so that I'll be able to answer the questions. All right. So for the label encoding, you have they both convert categorical data into numerical data. What label encoding does is it assigns a categorical value as an integer value based on an alphabetical order. So the label encoding assumes that there is an order in your colon, and it gives it a value, a categorical value based on a order. So it's actually good for ordinal data or ordinal data types, like data types that has to do with grades, or data types that has to do with maybe temperature, that has maybe high, low, medium. So it's good you can use a label encoding to convert that particular column to a numerical column. Like this column that we have here, I think there was a place we had one high, low, medium column here, where we have high, medium, high, low, medium. And here you can use a label encoding on this type of column. Yeah, but on a column that has no order, where you just have female and male, it's not like you're saying female is greater than male or male is greater than a female. So in this case, you can use your one-hot encoding to convert that column into a numerical column. So I'm just going to explain the difference between the label encoding and the one-hot encoding. All right, so for the label encoding, right, given a data frame, I'm just going to use a sample data set. We have a data frame that has a grade and a score. And you want to convert this grade into numbers. How do you go about it? You can use, in this case, okay, because it's a grade, right? A label encoding is the best is the best function to apply. So in Python, we have the pd dot factorize and the pd dot get dummies. All right. So, but then usually it's good to use the label encoder from sklearn.processing, because this uses some sort of modeling and algorithms. It's not just a function, so that it does not affect the dimension of your data set. So I'm going to go. I prefer using the label encoder function from sklearn.processing. So it's just the same way we did our feature selection. So you're going to import label encoder from sklearn.processing. and then you instantiate. You see that it's the same process. After you import, you do what? Instantiate. That is, you use the same name and then you put a bracket, open and close bracket in front of it, and you define, you give it a variable name. Now you use your fit transform. That is your LE. This is the new grade category I want to create. So I'm going to say df.grade new, or you can give it any name, right? Equals the label encoder dot fit underscore transform. So what this does is that it transforms that grade column into zeros and ones based on, it depends if you have more than one category, it gives it 0, 1, 2. All right. So when you print this, when you run this is what happens. You can see that this grade has been, A is now 0. Anywhere it says A, you have 0. Anywhere it says B, you have 1. Anywhere it says C, you have 2. So your label encoder has converted this grade column to numbers. So that is the label encoder. So now you can always use, instead of your grade, because if you use your grade in your machine learning model, you should throw an error for some classification or algorithms. So for you to be on the safe side, you can just convert it to a number. Now the what if is you want to use your one-hot encoding? The one-hot encoding, what the one-hot encoding does is that it creates new variables, that is, it creates new columns, and then it assigns a 0 to the place where you do not have anything on that row, and it assigns a 1 to where you have a value on it. So I'm going to explain what that means using the same explanation. So in this case, if you want to use a one-hot encoder for this grade column, now this same grade column, you want to use a one-hot encoder, you can just do the same imports sklearn dot processing one-hot encoder this time around. You create an instance using the one-hot encoder function. Then you assign it to a variable name. Then you do your fit transform. Now, the difference between your one-hot encoder and your label encoder is that you have to reshape, you have to convert this. You can either use your reshape function or you can do it this way. So I'm doing it this way. That is, this fit transform here. What I gave it here was just the column. I just selected the column grade and I gave it the column. I selected the column, the grade column, and assigned it as one of the attributes in this fit transform. But in this case, I had to use a double square bracket. And then not only that, I have to convert it into an array, because that is what fit transform one encoder works with, an array, because of the way the algorithm is designed. So this, I didn't want to do everything in this space. That's why I had to break it. So initially, after fitting it into this grade column, you have your encoded df. Then you can convert this to an array and have it in a data frame. So when you do that, this is what you finally get. Let me print out the encoded df so that you see what it looks like. You can see that what it did was that for grade A, now this grade, it created a new, it looked at all the unique values in this particular column. We had 3 values, so it made it grade A, grade B, grade C, right? Created a new column for each of them. So we have grade A, grade B, grade C. So under the first one, which you have A, right? He assigned 1 to grade A, and every other one he assigned 0. Then for the second one, because we have A, he assigned 1 to grade A and every other one 0. Then for the next one, we had B, he assigned 0 to grade A, 1 to grade B, and the other 0. And then for the last one, C, we have grade A is 0, grade B is 0, and grade C is what? 1. So that's what the one-hot encoder does. You see that it's different from the label. The label encoder is going to just give you one single column and then give it ranks. 0, grade A is 0, grade B is 1, grade C is 2. But then the one-hot encoder creates a new column for all the specific. So if you have like 6, 7 categories in that column, it creates the 7 categories. And then it starts picking each one of those rows and assigning 1 if it's actually that category, and 0 gives 0 as the other category. So you use one-hot encoding when there is no other in your data set. When your data set is like maybe male, female, or something else that doesn't, maybe you have occupation, you have something like location, you understand, something like that. So you can use your one encoder, but for your label encoder, you use it for ranks. Maybe when you have grade, you have maybe high, low, medium, or something. So use it to convert those ones to numbers. So now, having understood that, let's just quickly apply it to our data set. So because this is our the original data set, I want to convert this male and female to my numbers. So I'm going to use my one-hot encoding to do that. So before, I'm going to just do something like this. So because of our time, let me just copy what I have here. Okay, so we have this from sklearn imports instantiates. Now, one of the encoding my gender, that's what I want to confirm. So this data, I'm going to change it to data, and then I'll change this to gender. So my gender is what is male, female. I'm going to create a male column, and I'm going to create a female column, and then I have my encoded df. Data. Where do you have dates? Data. Let me just use df. Oh, okay, if I've had df on my data terminal. So now you can see that on my regional table, now you can see we have all of this. We have this gender colon. We have our male, female, right? Okay, great. Now, the next thing now is let's start building our model. So when I want to select my model, do my build my model, the first thing I need to do is to select my X and Y values. My X values now, in this case, I'm not going to select gender, I'm going to select male. Okay, even if I select gender now, you see that it's going to throw an error. Because why? Because, let me run it now. You see what I'm talking about. Let me select gender. Do your trains. Let me build my logistic regression model. Now, can you see what it's saying? It said could not convert string to float male. That is telling you that the male, it doesn't understand what male is. Can you help him to understand it, right? All right. So we have this let's keep the comments in the chat coming. I'll create time to answer them after this notebook session. All right, so we have this error message, but let's see what happens afterwards. So we're going to select all the features that we're going to be using. So our target column here is the purchase column, but the other features here, we're going to use age, estimated salary, then our male and female. All right, so we have this. So let's do that. Okay, there is an error. So because of the name of the data set, final df, final. Okay. All right, great. So now I've done my selection, then my train test splits. Now, your logistic regression model, you see that the way you applied your linear regression is the same way you're applying your logistic regression. You're just going to import the logistic regression from sklearn.linear model, instantiate it, logistic regression, just like the way you're doing to other algorithm models. We have the logistic regression. Then you can set a random state, that is, do you want to randomize do you want to, you can give it a random state, or you can use the default in there, and then you're going to just fit your data set. So that's just the process of building your logistic regression. You can see that it had already done that. Then you can do your prediction, and then you can do your calculation. So let me see what the name error is. Metric. So I'm going to import metric. So metric was not imported. Let me check where I had my import statement. From sklearn.metrics in okay. Import sklearn.metrics. Okay. I'd already import the full sklearn.metrics. So I'm going to use s sorry sklm. All right. Let me rush through so that I'll give some time for questions. So the accuracy score was 60. Precision was what's the problem? Let me check. Questions, right? Because I can see that we are having a lot to take in. Yes, you will get this notebook. Most times after the class, I get to upload it to the LMS because of this new updates I'm doing. So that you can have the updated notebook. All right. So you get it on the LMS. All right. So um we have the different classification metrics, classification metrics. We have the accuracy score. Accuracy calculates the difference between your it calculates the difference between your true values and your test values, and gives you the percentage of the ones that are accurately the accuracy of your data sets. If your true value is it's equal to your test value, find out that your accuracy score is 100%. So accuracy score tends towards 1 or 100%. So when you're doing your accuracy score metrics, all right. So but then for your precision and recall, there are formulas for it. we have some formulas for the precision and recall. So I won't want to go through the I won't want to go through the all the definitions, because I want the people to really understand it. So from next class, I'm going to introduce that to you. All right. So at this point, do we have any questions? So there are other models that I would want us to build, right? I want us to build we're going to try the same data sets with our the random forest classifier, naive Bayes, random forest, and then we'll try it with naive Bayes, random forest, and then the logistic regression. So we just tried it with the logistic regression, right? So we're going to continue from here during the next class. So I just want to give some time to answer the questions on the chat. All right. It's been a long day, and I'm sure that a lot of people are having a lot to take in. Okay, so let me just quickly go to the questions on the chat. I had to stop here so that we'll have some questions to be able to answer some of the questions, because I'm seeing that there are a lot of questions on the chat that needs to be answered. All right, so the first question says, to perform a linear regression on the feature, does it mean I will drop all other features and then use only one X feature and my target variable? No. I mean, after getting the best, thank you for the applause. Thank you all for for your commitment and staying on even up to this time. Okay, so the first question says that, does it mean that I will drop all my features and use only one X feature and my target variable? I mean, after getting the best score, say ZN is my best score, does it mean I will drop all the other X features except ZN? No, you're not dropping all the features. The problems in real life are not so simple. They are not that linear. You find out that the real life problems are very, very complicated. There was a time I was working on a project before Ethereum on one of this what's it called now? Bitcoin, all those, what do you call them? Bitcoin, it's Ethereum and all of that. The name just skip my head right now. Um okay. I was working on one of this projects, and then I got the real life data set. I went to Ethereum's website, got their data sets. I wanted to create an application that would, predict whether there'll be a rise of Ethereum. I'm sure we know what Ethereum is, just like Bitcoin, right? Cryptocurrency. Yeah, that was what I was looking for. Cryptocurrency. Yeah, predict the rise of Ethereum or the fall of Ethereum. Okay, so after all machine learning and everything, I discovered that I predicted the model that I built. I was working with some person with the team I worked with, and then it was able to predict accurately, not so accurate, but like I could say to some accurate level, right? About 6 months from now, what the price of Ethereum will look like, and whether it was going to go up or whether it was going to go down. So we created the time, but it's more into like time series forecasting. Okay, so when we build something like that, and then afterwards, and I noticed that 6 months from that time, what we actually predicted, we just saw that Ethereum started rising up, and it kept rising, and then what we predicted was, it was almost like it was very, very close to it. So it could happen that way, but sometimes you find out that because crypto market is a very, very volatile market. There are so many other factors. than all what we consider was just very big, was a basic model, very simple model. We didn't consider there are so many other factors that affect the rise and fall of cryptocurrencies. So you find out that the real world problem are not exactly linear. There's so many other things that you take into consideration. So it's not just one feature that you would use eventually for your prediction. You might have so many other features, but what you're trying to get is that you're trying to get as much as relevant features. Now you're focusing on relevant. You don't want to focus on features that are not relevant to your model development. And that's the essence of you doing your feature selection. I hope you got the question, the answer to the question. Okay, so the next question says, for regression model to have the best result, is it better to select just 30% of the feature or to set K to all? Thank you for your support. Okay, so to get the best result, most times you do a lot of iterations. There's no add and fast rule of what percentage of your data that you would use, right? You're As you're doing your data analysis, you're already seeing some features. Like when we're doing our data analysis, we notice that okay, maybe the gender could be a very good predictor because we are seeing some trends. You'll be seeing some trends. So that will be giving you ideas of out of 20 features, you'll be seeing some trends. And that's the essence of data analysis. People working on machine learning project, you're expected to be very, very good at data analysis. You might not be maybe all the gurus on visualizations and all, but then you can interpret, data analysis is beyond visualizations, but you can interpret some core visuals. You have some statistical background to know, okay, what is the difference? Why is this feature relevant? How would it impact my model? And so many other questions you're answering. So data analysis is very, very key. So when you're analyzing your data, you're seeing some features that are likely good predictors. So that will give you a range of the number of features that you likely select. And when you do your feature selection, you find out that most times those features that you've actually seen during your data analysis phase will be one of the top features. So you can now start picking. Sometimes you start iterating. You can, like all this model development you're doing, it could just be, it's because I'm training that I have to be splitting them into different cells so that you can understand what I'm explaining. So because most times if I lump everything up in a long code, it might just be scary that, oh, what is all of this? So most times you have to write a for loop. You look through each of those models, those iterations, so that your work will be fast. Because if you have to start writing one after the other, it can take the whole day doing that. So you have to start creating functions, writing loops around your model development and picking different cases. You can do like an iteration of select this first 5 column, build the model, get me the accuracy score, select the next 5 features, give me, something like that. So until you finally get your best results, at least to some confidence level. Are there fixed accuracy scores for prediction when using a logistic regression algorithm? Okay, there are no fixed accuracy scores for prediction, but what you're tending towards the 100% accuracy score. That is, most times in real life, you might not have an 100% accuracy, but then you are having a confidence level that I've tidied up all the knots, all the loopholes in my model, such that even if I have a model of 90% accuracy, right, with a particular confidence level, I can see that I know that it's going to generalize when it comes to a real life data set, because it's not just to have an 100% accuracy score and then when it gets to real life data sets it fails. So there are some models like that, and that's why we're going to be emphasizing on doing cargo competitions, Zindi competitions, because you get to work on some real life data sets, and then your you can benchmark when you're doing the competitions, right? Maybe we'll have a session like that, so I would introduce how to go about the competitions. You find out that they will reserve some part of the data sets. They won't expose all of the data sets for you. So they'll give you some training and test set. They'll reserve some real data sets. And then when you finally make your submissions, they'll compare your model that you've built with their own data set. So you get a different accuracy score. It's going to tell you whether your model is working well on their own data set or not. So as you do all of those things, you get better while building. I'm sorry, it's actually overwhelming. I can imagine. So for the idea of this boot camp, right, is number one, to get you started, and then to get you started in maybe for people that have not that have not done machine learning before, and then for people that maybe they are still on their way and they're still finding some concepts confusing, to get you started and to give you like a soft landing when it comes to building a career in data science and machine learning, because the journey is actually very, very, it's not just a journey of 2 months. It's a journey. It can take you 2 years, right, to really grow and become very, very good at it. So understand the part of you taking all of this in at once, but I want you to what you need to do is just take it step by step. That's why in this during this bootcamp program, we divided it into Python, Power BI, and machine learning, for the sake to just to accommodate different learning. Some people are beginners, some people are intermediate, just to accommodate different people, right? And then you can just do your project on any of the different. You could do your project on Python or Power BI or machine learning. But then afterward, and that's what the Data Gen Z is trying to build, such that you can keep growing in your learning journey. Afterwards, you're taking projects, you're doing, because if you don't do projects, if it's coming like this, right? Just learning, maybe just learning for 2 months and then you drop it off, and then maybe after some months or 1 year, you now pick it up again. It's like you're learning again from scratch. So you have to constantly work gradually. You have a kind of program that you're doing, you're working, you're learning, you're doing project, and as you're doing it, you see that you get very, very used to all of these concepts. Okay. All right, great. So don't be discouraged. I mean, you're very fortunate. Let me use that word, because when I was learning, I was coming into data. What I was saying was almost, well, it was just because I was resolute that I just have to. I just know that this thing is for me. This is what I want to do, because I came to start learning all the mathematics and the statistics, and it was so boring. There was so much practical approach. There were no resources at that time to say, okay, I want to start learning, and somebody be taking me from scratch, bit by bit. And then I had to do a lot of self-learning. So, and that's why part of the vision of, just giving people an opportunity to, learn easily when it comes to data science, because you can come across so many contents and then everything is just so confusing and you don't know what next to do. Recommend a cookbook for machine learning for reference on future projects. So there are several books that you can you can read on machine learning. I can drop some of them on the group. Okay, I'll drop some of them on the group, but be ready to read a lot of statistics and so many of the books, and except if you're watching videos, some of them are not very practical, and you have to read so many concepts. So you having boot camps like this gives you an idea of, okay, this is what it's like. So when you're approaching some of these things, you're not going there as a newbie. You're already having a background of what it's all about, then you can relate to it and you can get better. But I shared one book on Python for everybody on the LMS, but then can link other books as well. so that you can access. Okay. Oh, there are so many questions. Okay. The concept of label encoding also applicable in place of least comprehension method I just illustrated in handling categories. So it is different. Label encoding is different from the you splitting, changing your data sets to categories, like you categorizing the ages and all. So label encoding labels, there's a defined label. It gives your data, it gives a particular order, 0, 1, 2, 3. It's not like you're defining that order for it. It gives the order. All right. So it's different. Okay. The next question. Thank you for the interesting session. You're welcome. Okay. Opinion about the approach on the use of learning resources. At what point textbooks are better than visuals like video resources when learning difficult topics in data science? What is the approach of combining two learning tools during your early days of learning data science? So you have to understand how best you learn. There are some people that are visual learners. There are some people that just read books and they're very, very okay with books. There are some people that if it's not video, they can't understand. All right. So you have to understand um what kind of person are you? How best do you assimilate concepts? So that would aid your learning. That would help you, learn faster. Okay, so if you know that you're somebody that likes books, right, likes reading textbooks, right? So you can start off from there and combine it with video resources. If you're somebody like likes videos, right? So you can use videos more than textbook. But either way, you have to have a blend of the two, because there are some things that videos will not, there you can't learn everything on video. There's so many things that that are written in the textbook that you just have to find out for yourself. But I'm just a fan of project-based learning, because I've seen that gives most times beginners, it helps them to grab concepts easily, like when you're starting off. And that's why we are using that approach in this boot camp. Normally there are some boot camps that you just go to and then you do a lot of theoretical concepts. They'll take you through slides, theories, no much, just little practicals. And then you not start thinking, how do I apply this? How do I, but then I've noticed that the more you do projects, you come across several diverse problems, and then you have to start researching on your own, researching those books. It will drive you to start reading up on several books, and then you better understand what those concepts mean. All right, unlike you starting off with textbooks. And that's why it's also good to aspire. I'm glad so many people on this program, they are doing their masters. Some persons are doing their masters in data science, or some are doing their undergraduate studies. You can aspire to do advanced degrees. So that will drive you to learn. Because when you're doing a master's or PhD, you have to read books, you have to read papers, you have to read. It will drive you to do more intense studying, detailed studying. You have to learn algorithms and some things like that. So I would recommend you also, look further into that, growing your skill set. And passing through boot camps like this would also aid you, help you when you're doing your masters. Like we have had like 3 of our boot campers that passed through previous cohorts, and then they are doing well in their master's program on data science. All right, so the notebook, I'll share it. All the codes are in my head. It's as a result of practice and something. Sometimes, I don't know everything at once. Most times, especially if you're working with various, you've done different type of projects. Like it's been a while I've done. Sometimes I might just be focusing on deep learning. I'm doing neural network. So when I'm doing machine learning, sometimes I might have to just try to check up on. But because I've been doing it before, I just read some documentations and I remember, okay, this is how to apply it. Okay, so it's not like they are all in my head. I'm still learning as well. So you just have to also learn the art of the board game. Sometimes you might just be at a fix and then you just go to Google, chat GPT. How do you, it might be as simple as how to concatenate. You might just forget that and you just be wondering, okay, how do I concatenate? You just go to Google and how do you concat? And when you just say PD, oh, you just say, okay, PD dot concat. Because you've used it before, you don't have to start thinking of how do you use it. You just remember and then you apply it. So that's how you learn. Thank you. Glass of water. Yes, I think I need it. All right. Okay. It's a pleasure, everybody. Thank you so much. I think I've answered all the questions. Okay. Thank you all for joining. Okay, I'll drop my LinkedIn profile. I think I had dropped it before, but I'll just let me drop it again. But I just want to encourage you all, please don't be discouraged. It's very, very interesting and it's a very it's a very promising field. It's a very, very promising field. And then the sky is the limit. It's not, I mean, it's the starting point, not the limit. What am I saying? The sky is the starting point, and just keep learning